For this section, we are finding the measure of inscribed angles and inscribed polygons. We've already talked about some of this last week, but here we have some specific notes about it. So the first one here, it's got a theorem, and it says the measure of an inscribed angle theorem. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So to fill in this theorem, the inscribed angle, which is ADB, is 1/2 of the arc that matches with it. So over here I have a sample problem using that rule. The angle is 1/2 of the intercepted arc. So we can work this out. Doubling the angle is going to give us the arc because the angle is 1/2 of that arc. So if we do 2 times 37, we will have the measure of that arc. So that would be 74 degrees would be the measure of the arc, 2 times 37. Then we have another theorem here, and it's saying if 2 inscribed angles of a circle intercept the same arc, then the angles are congruent. So this intercepted arc from A to B relates to the angle at D and the angle at C. And they named it with 3 letters here in the rule. ADB would match with ACB. So those would be congruent because they intercept the same arc. So in this picture over here, on the right is a sample. So right here, this is a sample problem dealing with that. And they are asking us to find angle B. This angle at B intercepts arc from A to D, which is the same as what angle C is doing. So if I can figure out what angle C is, then it will be the same as angle B because they intercept the same arc. So I've got a triangle in that in the bottom there, and it's got 2 out of 3 angles labeled. We've got the 32 degrees and the 116 degrees. So I'm going to use that and the fact that a triangle adds to 180. So if I take the entire triangle, which is 180, and I subtract the 116 and then subtract the 32 degrees, that will give me what's left. So let me double check that here. You get 32. So this angle right here at C is 32 degrees. And that means that this angle at B is also 32 degrees because they intercept the same arc. So angle B is 32 degrees. If they had asked for the arc, you'd have to double 32. The arc would actually be 64 degrees. So the next theorem here is talking about if a right triangle is inscribed in a circle. Inscribing a right triangle means that the vertices of the right triangle are all on the edges of the circle. So you can see in this picture, A, B, and C are all on the edges of the circle. If it is a right triangle inscribed, then the hypotenuse is the diameter of the circle. Conversely, which means to flip your statement, if one side of an inscribed triangle is the diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. So in this picture, the measure of ABC equals 90 if and only if AC is the diameter of the circle. So in this picture here to the right, they're asking us to find the measure of angle B, and seeing the dot on AC tells us that that is the diameter. That's the way that the book sort of shows a diameter. And that means that angle B would be a right angle because it'd be a right triangle. So the measure of angle B would be 90 degrees. And then the last rule here on this page is that a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So in this picture, we've got a quadrilateral in a circle, and it says D, E, F, and G lie on circle C if and only if angle D plus the measure of angle F equals the measure of E plus the measure of angle G equals 180. So if the opposite angles add to 180, then the polygon is inscribed in the circle. Also, if you know that it's inscribed in the circle, then you know the opposite angles add to 180. So we've got a sample over here to the right, applying that rule. Angles opposite from each other would be like angle J and angle L. And so it's an inscribed polygon, or inscribed quadrilateral in the circle. So the opposite angles are supplementary, they add to 180. So if I add them together, they equal 180. So subtracting 110, 5x equals 70, divided by 5. X is 14, that's how we would solve for x there. And then to solve for y, same kind of thing. These are opposite in an inscribed quadrilateral, so they're supplementary as well. So 2y plus 104 equals 180. Subtracting 104, you get 76, and dividing by 2, 38 for y. So that's x and y. And then here at the bottom, we just have an extra sample here, and it's a multiple choice question. It says, in the figure shown, which statement is true? And so they're asking you which pair of angles is congruent. And over here in the picture, they don't have anything really labeled. So what we need to use for this picture is we need to use the theorem where they're intercepting the same arc. This is arc SR from S to R around the edge here. And the angles that intersect that have vertices of P and Q. So we need to look and see, do any of these angles have vertices at P and Q? This one has vertices at P and at Q. And so let's see, do they name them right? RQS, R to Q to S, and then RPS. So they did name them right. So this one is true based on those two angles. The only other thing that could happen that would be true would be to use the arc from P to Q, and its angles would have vertices of S and R. So you need to look for if they had any that had vertices in the middle that are S and R. So looking in the middle is the middle letter S paired up with R. None of these do have S paired with R, so that would not be the pair of angles that you'd be looking for. So all of these others are not true because we look for the two that would be true. So B would be the answer, the only answer that works there.